All right, so we're in our final lesson. All right, so what we're looking at now is piecing everything together in terms of voltage, current, and resistance when talking about or dealing with the circuit. And again, what we're going to also use is everything we've learned. So Kirchhoff's voltage law, Kirchhoff's current law, and also Ohm's law, which is the V equals IR. Now, I enjoy these types of problems because they're like a puzzle. There is not a starting spot. What you have to do is try to find the simplest piece first. And then if you can't do that, then move on to a more complicated piece and then kind of work back and forth. Again, much like a puzzle. Now, in this situation, here's our first example. And what we're looking at is we just have a circuit here with two loads in series. All right. And what the question is saying is, find everything that for each load and the circuit. So find our voltage, our current, and our resistance for the entire circuit. All right, so we only have the voltage here, the resistance here, and the current here. And again, it's like a puzzle, and so you try to fill the simplest pieces first. Now, I see that I have a current of 4.5 amps. Now again, because of Kirchhoff's current law, the current in is equal to the current out. And so if 4.5 amps came into this circuit, then 4.5 amps also went through resistor number one, which also again means 4.5 amps came from the source, again, because current is the amount of charges. So 4.5 went through, came out, 4.5 went through this one, and returned back to the source. All right, now, still looking at information. Well, I've got 2 out of 3 here and 2 out of 3 here. So what I can use is Ohm's law, V equals IR. And I have a voltage of 90, a current of 4.5. And I can find the resistance. So I'm going to divide both sides by 4.5. And so let's see here, I have clear 90 divided by 4.5, and I'm getting 20 ohms. So there's another value. Again, I can use V equals IR for our first load. And so this time I can find the voltage, which is just going to be 4.5 times 12. And I end up with, let's see here, 4.5 times 12, 54 volts. Now, here's the key, is I'm down here, I do not have 2 pieces of information, I only have 1. But now I'm going to bounce back and use Kirchhoff's voltage law. So each charge leaves with 90 volts, all right? 54 are used in the first load, so the rest must be used in the second load. So V2 here is going to be 90 minus 54, which, let's see here, 90 minus 54 gives us 36 volts. All right, well, now that I know 2 of them, again, I'm going to use Ohm's law, V equals IR. I have 36 volts. The current is 4.5. And I'm going to find the resistance. And so again, I'm going to divide both sides here by 4.5. And so I take 36, divide it by 4.5, and I end up with 8 ohms. Now again, because this is all interconnected, and you can see how I bounce back and forth between using Kirchhoff's voltage law and Kirchhoff's current law, and also Ohm's law. Now, that last part there, where I figured out the 8 ohms, well, because I could have done it a different way in that I knew this was 12 ohms. This is in series, and so our equivalent resistance for the entire circuit was 20. Well, 12 plus something would have given me 20. And in this case, I could have just figured out, well, it's 8. So there is multiple ways to figure things out. Again, it's like a puzzle. All right, let's try, we'll get a little more complicated here. So we get to example number 2. And so let's see what we got here. Make sure, whoa, don't want to ruin my markers here. All right, so the next one we have, let me see here. Here's our source. Oops, there we go. There's our source. We go up. We have a resistor there. All right, and it's in series, and then all of a sudden we have a parallel part. All right, and so they are connected, and then let's see here. Then it goes down, around, all the way to my source. Oh, that's a bad pen there. Let's see if we can get a better one. All right, now the information given here. First off, I'm going to go VO, IO, RO. We're going to figure everything out. And for this source, we know it's a 9-volt source. All right, we have our first resistor up here, so it's V1, I1, R1. And what do we know about just the resistance? 6 ohms. All right, next up, we got number 2 here, so I'm going to call it V2, I2, and R2. And I believe we know the resistance, 20 ohms. Okay, and then finally down here, our third one, so I got V3, I3, and R3. And what do we know here? We also know the resistance. Okay, so here we go. So what can we figure out now? Again, it's a puzzle. I do know all the resistances for each of the loads, which means I am going to be able to find my RO, which again is the equivalent resistance for the entire the circuit. Now, I have loads in series, but I have a parallel inside a series. So what I'm going to do is, like I did earlier today, I'm going to combine these 2 resistors. And so I'm going to find what's called R23. And again, because they're in parallel, I'm going to have 1 over 20 plus 1 over 30. And again, to the minus 1. All right, now 1 over 20 is 0.05 plus 1 over 30, which is 0.03, and again to the negative 1. All right, so I add those 2 together and I get 0.08, and then I do it to the negative 1, and I end up with a resistance of 12 ohms. Now that's just these 2 put together. We do have an R1 here, so I can find my equivalent resistance for the entire circuit by taking R1 and adding it to R23. Because again, they are in series. And so let's see here. R1 is 6 ohms, plus we got a 12. And so our RO here is going to be 18 ohms. All right, so there we go. All right, so that's part of our circuit. Now again, I got 2 out of 3 here. So I'm going to use now Ohm's law, where I go V is equal to IR. All right, so my voltage is 9. And my markers are terrible. Let's see here. End of the year, they're running out here. All right, so we're finding I. R is 18. All right, so if I divide both sides by 18, RO is going to be 0.5 amps. All right, now, again, it's a puzzle, bouncing back and forth. Well, if I know the current from the source is 0.5 amps, well, then going through this part right here, the first resistor, the only place those charges could go is through it. So there we go. We have 0.5 amps there. Now, those charges split up here, and I don't know how they split up. So that's going to be a little bit challenging. But we only got 4 values left. But again, I got 2 out of 3 here. So I'm going to use V equals IR. And in this case, I'm going to take 0.5 times R, which is 6. Well, what's half of 6? 3 volts. There we go. So I got that one now. Now, because I know, again, I'm using Kirchhoff's voltage law, 9 volts leave this circuit. 3 get used up on our first load, but then they can split up. But either way, no matter which way they go through resistor 2 or resistor 3, we've only got 6 volts left and they have to use it up. So 6 volts here, 6 volts here. All right. Now again, we got 2 out of 3 here, 2 out of 3 here. And so what I can do again is use V equals IR. My voltage is 6. I'm trying to find the current and resistance is 30. And so this time I'm going to divide both sides by 30. All right, and 6 divided by 30, let's see here, is 0.2 amps. Now, I got 2 out of 3 here. I could use V equals IR, but again, with Kirchhoff's current law, 0.5 amps come through to this spot, 0.2 go this way, which simply means 0.3 must go to our top circuit or top load. And there we go. We've got all the voltages and the currents and the resistance calculated for each part of the circuit. Again, it's a puzzle bouncing between all 3 laws using them. All right, so let's try a couple more. All right, so next up, let's see here, C. Guess I'm not doing example 1, 2, 3. I got A, B, C. All right, so example C here. Let's see here. So I got my source over here this time on the draw diagram. So again, the big's positive, negative, doesn't really matter. All right, so we go up, across, all right, down. There's our resistor. All right, and let's see here. Over here, we got 1, 3. Whoa, that's a bad diagram. All right, doing my best there. I'm not a very good artist. My markers are all drying out on me for some reason. All right, so now what do we have here? I'm going to label them first of all. Here's our source. So we have a V0, I0, R0. All right, this one here is, let's see here, R1 here. So this is V1, I1, R1. And this one here is labeled as 2, and this one's 3. So we get a V2, I2, R2. And same down here, we got a V3, I3, and R3. All right, now, let's see here. What do we know in this diagram? Again, we know a bunch of resistances, and we actually know that's 5 volts right there. Our resistance here is 40. We got a 30 here and a 10. All right. So once again, what I see is that I know all my resistance, or I got all my resistances here. So I've got R1, I've got R2 and R3. So I will be able to find R0. All right. And so first off, I can find R2, 3 by combining R2 and 3 here. So because they are in series, all I have to do is add them up. That's always a good thing. All right, so I just take my 30 plus my 10 here. And of course, that would be 40 ohms. All right, now, again, I'm looking for R0. So I've combined these two. But again, R1 and these two, R2 and R3, are in parallel to each other. So I'm going to find R0 by, again, using my parallel formula, where I'm going to have to take R1 over 2, 3 plus R1 here, 1 over R1, and again, take it to the -1, power of -1. And so R0, let's see here, again, R2, 3 is 40, so we got a 1 over 40 plus a 1 over 40. All right, and now let's see here. As a decimal, 1 divided by 40. I get 1 divided by 40, 0.0 0.025 plus 0.025 because it's twice. Now, if I add those together and go to the power of -1, I end up with 20 ohms. So I can put that right there. There's our R naught. So that is the equivalent resistance of the circuit. Now, again, I want to find out all the other information. And here I got 2 out of 3. And so I'm going to use V equals IR, Ohm's law. Voltage is 5. Current we're going to find out. And 20 is the equivalent resistance. All right, so again, I want to get I by itself here. So I'm going to divide both sides by 20. And my current, whatever 5 divided by 20 is, should be 0.25. And it is 0.25. So there is 0.25 amps through this circuit. All right. Now, where are we headed now? So we got all those. Our voltage is 5, our current. So now I'm looking to see what else could I figure out. We've got our current. We don't have any of these yet. Let's see here. So we leave the source. Did I miss any information here? I don't know. Now, again, puzzle. Where are we going to go with this? The current splits up. We don't know how it's going to split. The voltage is 5. So our voltage, again, Kirchhoff's voltage law. If we're going through, the charges have to pick a path. It's either going to go down V1 or it's going to go down the path where you got to go through V2 and V3. Now, if it goes through V1, it has to use up all 5 volts. All right. Look what we got going on here. Again, 2 out of 3. So I'm going to use, again, Ohm's law. So V is equal to I divided by R. All right. And so I'm going to divide both sides here by 40. And so the current going through resistor number 1, I take 5 and I divide it by 40 and I get 0.125. All right. Now, again, the current is 0.25. So if 0.125 go this way, the rest go the other way. And let's see here. So I take 0.25 and I minus 0.125. And in fact, I get 0.125. It's basically half. It is half. Half go this way, half go that way. So if 0.125 go through resistor number 3, well then 0.125 have to go through resistor number 2. And now finally, look at this. We got 2 out of 3, 2 out of 3. So for both of them, I'm going to use V equals IR, Ohm's law, where our voltage, in this case, I'm going to have 0.125 times 10. And so I'm just going to move the decimal place here. I'm going to use up 1.25 volts. All right. Now I could use V equals IR here again, but I'm going to decide to use Kirchhoff's voltage law. We got 5 volts. If our charge picks to go down this path on the far right, it's got 5 volts of energy to lose. It loses 1.25 here. The rest must be used here. And so I'm going to take my 5 volts, subtract 1.25, and that means it's going to be 3.75 volts. And there we go. So again, it's a puzzle. All right, so one more here. One more example for the end of the year. All right, so let's see here. All right, so our last example, let's see, I've got my source over here this time. All right, it goes down. We have our resistor down there. Then it goes out, and then it goes into a parallel. So we go up. Whoops, squiggly line. So it gets to pick which path in those two. All right, and then we go here. We have another resistor right here, a load or a resistor, same thing. All right, so how do I have this labeled? We got 1, 2, 3, 4. All right, so I have a V1 here, I1, R1. Over here it's V2, I2, R2. And over here we have V3, I3, R3. And then finally, number 4 here, V4, I4, R4. And I can't forget my source. So that's our V naught, I naught, R naught. Okay, now what do I know here? So what do we got? We got the first resistance here is 10 ohms. All right, we have a 20 here. We have a 80 here. Okay. Down here is a 4. And probably we don't know R naught, but we do know the voltage is 45 volts. Okay, so is that everything we got? Yep. All right. So again, because we know all the resistances here, again, I'm going to find R naught. Now, before I do that, I have it's in series, but we have a parallel part in series. So I'm going to combine these two, R2 and R3. And so what I'm going to do is, let's see, we'll go up here, R23. So combining the two, now they are in parallel, so I'm going to have to use my parallel formula for resistors. So I'm going to have a 1 divided by 20 plus a 1 divided by 80, and of course to the power of -1. All right, now what do we get there for 1 divided by 20? All right, we have, let's see here, 0.0125. It's kind of important not to round with this formula because you can sometimes get weird numbers and things just won't quite work out if you round a little bit. So 1 time. All right, then we have 1 divided by 80. Whoops, that's 1 divided by 80. 1 divided by 20 is 1.05. Just rolling down the wrong order here. All right, so I add those two together. I take it to the power of -1, and I end up with 16 ohms. Now that is combining resistor 1 and resistor 2 and resistor 3. Now, to find RO, now we have them all in series. So all I have to do is add them up. Where R0 is going to be R1, plus we combined our 2 and 3, so we got R2, 3. And then we got 4 down here, can't forget it. All right, so our resistance for the circuit, we have a 10 for resistor 1. We combine these two together to get a 16. We got 4 here, which is 4. And so let's see here. 10 plus 16 is 26 plus 4. We got 30 here. All right. Now, I got 2 out of 3 here. So again, I'm going to use Ohm's law. All right, so my voltage is 45. My current, that's what we're figuring out. And I got a 30 here. All right, so to find my current for the circuit, I'm going to divide both sides by 30. And my I is actually going to be 1.5 amps. Perfect, so I know everything about the source. Now, again, it's a puzzle, so what can I do next? Well, since I do know the current, if 1.5, because again, current is the amount of charge. If it goes through if 1.5 leaves, well, it has to go through number 1. Then it gets to this junction point here, this parallel part of our circuit. It picks. So we got 1.5 of them. I don't know how many go down door number 2 here, and how many go down door number 3, but they do combine back up and do go through I4. They all have to go through I4. All right, well, look I got 2 out of 3 here, 2 out of 3 here. And so again, I'm going to use V equals IR on both, which in this case is just going to be 1.5 times 10. In that case, that would be 15 volts. All right, I'm going to do the same thing down here for resistor number 4. I'm going to use V equals IR. And again, this time, I got 1.5 times a 4. And I'm going to get 6 volts. All right. Well, now we get to over here. Now I'm going to use Kirchhoff's voltage law. I know 45 volts leave the source. And no matter what, again, as they go through the circuit, they come back with 0. Well, if they lose 15 here and they lose 6 here, that means that they have used up a total of 21 volts. Now, whether they go down door number 2 or door number 3 here, they got to use up the rest. And if I take 45 and I subtract the 21 volts it's used up, I get 24 volts are left. So again, because it uses 15 here and 6 here, 24 volts must be used here, and 24 volts must be used on also resistor 3. So no matter what path our charge takes, 45 volts are used up. Well, here we go. We get 2 out of 3, 2 out of 3. So here we go with the Ohm's law again. V equals IR. So I got a 24 equals I and an 80 over here. Whoa, it's going to be a decimal here. I'm going to divide both sides by 80. And I have no idea what 24 divided by 80 is. Let's see here. I get 24. Whoops, clear. 24 divided by 80. 0.3 amps. All right. Now, I could use Ohm's law again here, but again, with Kirchhoff's current law, 1.5 amps leave the source. That's the how many? 1.5 go through here. Then they have to make a choice. Well, if 0.3 go down circuit number 3, or load number 3, well, then the rest have to go down load number 2. And so the difference between 1.5 and 0.3 is it's 1.2. And there we go. We've got everything completed for our circuit. And like I said, I'm a big fan of these types of questions because it's like a puzzle. And again, there's nowhere to start or where to finish. Sometimes you can use Kirchhoff's voltage law, current law, and Ohm's law. But again, you got to bounce around. The key thing is, I find, is figure out what the easiest stuff is, with the information you got. And then if you have to get into the harder equations, you got to do it. So anyways, that is the end of this course. I don't want anybody crying.